Alright, welcome back. This is the second video in the series about build-up, staking, and overhangs. If you haven't watched the build-up video already, I highly recommend you go back and view it first. We're going to be discussing stay-in-place forms and deck panels. These are the two most common types of deck forms we use in North Carolina. On the left, you'll see concrete deck panels. On the right, you'll see stay-in-place metal decking. And normally you're only going to see the pre-stressed concrete deck panels in highly corrosive environments such as the coast. They're limited to maximum 5-inch buildup, and most other bridges you're going to see in the state are going to have the corrugated stay-in-place metal decking. The third type that you might possibly see is removable forms, but most of the time you'll only see those in a closure port area or if you're working on a railroad bridge. Now, deck panels are precast, pre-stressed panels that are used in conjunction with concrete girders, and they serve not only as a form, but they are the bottom half of the deck. So they're a structural part of the deck in its final condition. They essentially take the place of the bottom mat of reinforcing steel and the bottom half of the concrete. The edges of these deck panels rest on polystyrene strips, and those strips are cut to the proper buildup height so that these panels are on the proper elevation to form the bottom half of our deck. You'll also have weep holes in them, which alternate high and low weep holes to allow excess water and air to escape during the deck pour. Here's a picture of a pre-stressed concrete deck panel, and we see the pre-stressing strands coming out of the side here. These are lifting loops with which to lift the panel into position. You see the polystyrene strip which is holding the concrete deck panel up, and you can tell by the shadow that there's a little bit of an overhang. This will be there's a minimum overhang called for in the plans, and normally it's like an inch, inch and a half. Now, this picture, you can also see this overlap. Now, the purpose in that overlap is we want to get concrete underneath the edge of the panel to try to eliminate any girder line cracking. And so if we're trying to get concrete under the edge of the panel, that's why we need the weep holes to let the air out so we don't have honeycombing under the edge of this panel. Buildups are normally somewhere between 1.5 inches and 5 inches on these panels. If you have buildups that fall outside of that range, you need to contact your area construction engineer. Now, you don't want to allow heavy loads to be placed directly on your panels. This bundle of steel in the middle here is correctly stored. You don't want concrete buckets, heavy bundles of reinforcing steel, other equipment stored on top of the panels themselves, though. The panels will come with, you'll have a set of shop drawings for the panels. The panels will be numbered, and they'll tell you where each one of them goes. This is, of course, especially important if you've got a skewed section at the end. And the panels should always be pre-soaked, just like the top of the girder before the deck pour. You want both the panels and the top of the girder in a saturated surface dry condition. This is because if the girder or the panels are too dry, they can actually suck moisture out of the concrete in your deck, and this could cause cracking, and it could also cause delamination problems. Now, this is a picture from the build-up video, and you can see we've got the 1.5 inch overhang right here. This is polystyrene strip as well as this one. In this example, as all of them, the top of the girder should be flat, and we've got a super elevation. So due to this super elevation, you've got a higher buildup or a higher polystyrene strip on this side, on the high side of the super elevation, and a shorter strip or a shorter buildup on the low side of the super elevation. Just another shot of the end of the installation of a concrete deck panel. Again, we see our polystyrene strips. We see the overhang. The contractor has formed in the into the diaphragm with plywood here. We can see our lifting loops. Now, if you have cracking in your concrete deck panels, this is always a concern. And any cracking, you need to notify your engineer. These panels should be checked as they're coming off the truck. They should be carefully unloaded and carefully stored. And if you see any crackings, the panel should be marked or set aside and contact the engineer so the cracking can be evaluated. You also want to check after they are put in place so that you make sure that there's no further damages happen in handling going from where they're stored to their final position on the deck. All right, next we've got metal stay-in-place forms. A couple of things about this picture. You can see the angles which are holding up the metal decking. We'll look at that a little closer in a minute. And here's a place where we've got removable forms in this closure pour. All right, the metal stay-in-place forms are pretty much just corrugated sheets of steel. And for steel girders, you take an angle and weld it directly to the top flange in most locations, and that's what supports your metal stay-in-place decking. Now, there's an exception to this, and if that metal girder has a no weld zone in the top flange, if it is a section where the top flange is in tension, we can't weld to that spot. Now, the reason for this is welding to the steel in tension is a place where cracks could potentially develop, so we don't want to do that. We'll go over that in just a minute. And anytime that you're welding to structural steel or anything on the bridge, basically, you need to have a certified welder. If you've got any questions about certified welders, you can contact your M&T representative, or you can contact your area construction engineer, and we'll be glad to discuss it with you. All right, here's a shot of a steel girder with the angles supporting the decking welded directly to the top flange. And you can also see on this side that the overhang support brackets are welded directly to the top flange. So I've talked a little bit about tension zones or no weld zones. What is that? The example we've got down here is a simply supported girder, simply supported beam, and we'll say that this line through the middle represents just the middle of the girder. If we apply a load to that girder, the girder's going to deflect, so the middle of the girder is going to look something like this. So we push down on the girder and it's going to bend down. What does that do to the girder? It makes the bottom of the girder want to go in tension because it's trying to get longer, and the top of the girder is wanting to get shorter, so it's going into compression. Now, a way to think of that is I've taken a piece of PVC and feathered it, and the gaps are basically even. If we bend that girder, that piece of PVC down and deflect it, you can see that on the top, the spacing in there gets smaller, and the spacing down here on the bottom gets larger. So what's happening there is, as I bend it, the bottom is wanting to get longer. It's in tension. It's being pulled apart. The top is getting closer together. It's in compression. So at the bottom of our curve, we've got tension on this example, and the top we've got compression. So that's a simply supported girder. Let's go to a little more complicated case. As I said, you've got tension in the bottom and you've got compression in the top. But let's go to a little more complicated case where you've got continuous steel. In this situation, same thing, we've got the blue line representing the middle of the girder, and we place a load on it, and the girder deflects. So what happens there? We end up here at the bottom in the middle of the spans, and at the top over the bearing, we end up in tension. So the top of that girder over the bearing is being put in tension. The top is spreading out, it's trying to extend, so it's in tension, and the bottom of the girder is being shoved together, so it's in compression. So this area would be a no weld zone. This area is a tension zone. On your plans, you should have a note stating that there is a no weld zone or a tension zone, and it will give you stations between which you're not supposed to weld to that top flange. these areas would be in compression, and it would be fine to weld to those. So what you will normally see is this is an area with a no weld zone. You have these ladders is what they're called. And what's happened is the contractor has taken angles spanning across transversely across the top flange, and he has welded the decking support angles to those. And so he never has to weld directly to the top flange. You should always, after the steel is set, mark the locations of those no weld zones clearly so that nobody tries to weld in that area. Now, on a concrete girder, you can see that there are metal clips cast into the top of the girder for welding this angle to. Side note, in this particular situation, there was either a fabrication error or some very excessive sweep in this girder, and the end of the metal decking panel had to be trimmed off. Now, it was trimmed off evenly from one end to the other, and in this situation it didn't cause any loss of strength in this decking, but the ends still had to be sealed up. You don't want to have concrete flowing through this hole during your deck pour, so we had to have some sort of closure here. All right, this is a picture that comes directly from the previous video, and we've got a girder here, the top of which is flat, and this girder is on a super elevation. So along the center of this girder, our buildup, or our distance from the top of the girder to the theoretical bottom of the deck, is 2 inches. But due to this super elevation, on one side, on the high side of the super, that buildup is 2.4 inches, and on the low side of the super, it's 1.6 inches. Now, contractors use various methods they can construct different types of jigs to set this, but you need to make sure that you have got each edge properly marked. You've got the correct buildup marked on the correct edge. Now, back to our example, we've got a 04 super, the top of the girder is flat, and this the red line represents the theoretical bottom of the deck. So we're going to want our decking forms suspended in here somehow to where the top of the decking form is even with the bottom of the deck. Well, how do we support those deck panels? We weld the angle. As we saw in a previous slide, there's a metal tab in the top of this concrete girder that you can weld this angle to, and we weld it in a fashion to where this distance from the top of the girder to the top of the form is going to be our buildup height. In this situation, we have the angle in here in a 7 position, which means that the flat leg is on top. So this is either a 7 or a backward 7, however you want to look at it. And it allows us to weld a fillet weld in here. Now on this other side, the bottom of our decking is going to be below the top edge of our flange. So if we try to put a piece of angle in there in a 7 position, it's going to be so low that we can't weld it to the tab in the top of the girder. In that situation, you have to flip that angle over into what is called L position, and it allows us to weld on the back side of this leg and the decking to be supported by the lower leg of the angle. Some of the things to look for when you're welding this is there's a problem here. The problem in this situation is that the buildup for the right side was marked on the left, and the buildup for the left side was marked on the right. And what has resulted is this sawtooth pattern. We've already established that the top elevation, or the top surface of this deck panel is supposed to be forming the theoretical bottom of our slab. So it should be parallel to this line right here. It should look something like this. So if you ever see this sawtooth pattern, something's wrong. You should see something like this. This can easily be checked before anything's even welded, just as soon as the buildups are marked. You take a string and stretch it across through here. You measure up from this corner, measure up your buildup height to the string. Measure up from this corner to the buildup to the string, your buildup height. And check your buildup height at each of these other locations to make sure that if it says there's a 3-inch buildup right here, it's 3 inches from the top of your girder up to that string. If it's not, then you need to go back and check things again. All right, the lap direction is also important in metal decking. There's going to be, for most pours, a pour direction. You can go to some of the videos on setting up a screed and it'll tell you a little bit more about this. But basically, if your pour direction is going from right to left, then your decking should be installed from left to right. Or if your pour direction is going from up station to down station, your decking should be installed from down station to up station. The reason for this is we've got this piece of decking in here and it's got the little lip sticking out on this end. When we install that next piece of decking, the lip on the second piece of decking sits on top of the lip on the first piece of decking. Now when we pour, as the concrete is poured, this top piece of decking is pushing down on that joint on the first piece of decking we laid, and it's helping to seal that up so we lose less grout. In this example down here, the ends of these two pieces of decking, which are right here, you lap them over like this so that when the concrete is cast, it is pushing down and squeezing that gap together so that we're less likely to lose grout. You may run into a situation where the decking is installed backwards, or you may run into a situation where the pour direction was changed for some reason and you're pouring in this direction, which you're pouring on the bottom piece of decking first. If you end up in that situation, you should take some extra precautions to make sure that you don't have leaks. That may include adding additional screws in the lap right here, or it may be trying to seal this edge, but make sure that we don't have any leaks. All right, end closures. This is the end of a bay. Here's our diaphragm, and this is our end diaphragm. You can see that this piece of decking is cut on askew. Now, with the piece of decking cut on askew, as opposed to the one we looked at previously that was cut straight down the edge, this has affected the strength of this piece of decking. These angles on your shop drawings are designed for closure. They're not really designed for support. So there may be situations where you have to have additional support or stiff legs off of the cap or something to help support this end of the form. In this particular picture, you've got a diaphragm that you can weld this angle to, which helps support the end of the decking. If it was that closure pour that we looked at earlier, there may not be a diaphragm between the two last girders in the closure pour. So you may end up having to have additional means to support the end of this metal decking. All right, trimmed edges, I mentioned that earlier. Make sure if you do end up trimming any edges that you close that up so that you don't have a place like this where concrete can leak out and get in the creek or on cars or some other place. All right, lastly, inspectors are supposed to sound after a couple of days at least 50% of the panels. This is done from the bottom, normally with a hammer or a piece of rebar, and you're just sounding to make sure that you don't find any hollow sounds. So if you do find a place with a hollow sound, that could mean that there's a honeycomb place or a void behind that panel, and that panel would need to be removed so that it can be further inspected. One place that this test will not work, sound in the panel, would be that if you have a lightweight deck, many times there's something called an excluder plate. Excluder plate lays on top of our metal decking, and what it does is it keeps the concrete from going into the corrugations, or it excludes the concrete from the corrugations. That makes the deck lighter. And if you do that, as you can imagine, if you start hammering on the bottom side of these forms, you're not going to hear much. It can sound like it's failing when it's not. In those cases, a piece of decking may have to be removed for inspection because sounding it won't do any good. All right, I appreciate you watching the video. The next one will be on overhangs, and I hope you'll come back to view it as well.